Hi everyone, my name is Lisa Pitsi and this is the pre-recorded Introduction to Linux Services session for the CHPC Student Cluster Competition 2026 selection round. A Linux service is a program that runs quietly in the background with no visible terminal window. It starts automatically when the system boots and keeps running until it's stopped. A simple analogy would be thinking of a restaurant kitchen. Customers don't see it, but it works constantly to keep everything running. In Linux, we often call these background programs daemons. That's why many service names end with D: SSHD, slurmd, NFSD. These daemons start before any user logs in and form the backbone of a multi-user, multi-node system. Every time you SSH into a machine, SSHD is the service answering your request. If someone stops SSHD, you lose access. Services are what keep the cluster reachable and functional. After this presentation, I'll share a short demo video showing you everything in action. So why Linux services matter in HPC? Linux services are absolutely essential in HPC environments. Every node depends on them. If a critical service stops, the cluster breaks. Schedulers like Slurm are services. Storage systems rely on services. Monitoring tools rely on services. When something goes wrong on a node, debugging almost always starts with checking the server state. If one service fails, jobs can't run, files can't be accessed, and the cluster becomes unstable. Before we dive into Linux services, we need to understand a few essential Linux commands. These are the foundation of everything else. I recommend completing the Try Hack Me Linux rooms. They're a great way to test your understanding of basic commands in a hands-on way. So now we're moving on to SSH. SSH, also known as Secure Shell, is the protocol we use for secure remote access over an untrusted network. When you generate an SSH key, you create a key pair. Pair meaning two. So you have a private key, which is kept securely on your machine, and you have a public key, which is stored on the server. Some essential SSH tasks include connecting to a remote machine, generating a key pair, and also copying files between machines. I've included an SSH reference sheet in case the concept still feels a bit unfamiliar. Let's move on to networking. Networking is critical in HPC. Without it, nodes cannot communicate or share files or even run distributed workloads. So some key components that are included in HPC are your network interfaces. These represent the physical or virtual network cards. Tools like IP or fconfig configure them. You've got IP addressing, you've got IPv4 and IPv6, which identify devices on the network. You've got routing. This determines how packets move between networks using routing tables. You've got DNS, which translates human-friendly names into IP addresses. You've got firewalls as well. Tools like IP tables and NF tables control which connections are allowed or blocked. Now we're moving on to bash scripting. If you've coded before, bash scripting will feel very familiar. A bash script is simply a sequence of commands written in a text file and executed by the bash shell. It's vital for automating repetitive tasks, for managing system operations, and also for combining multiple command line tools into one workflow. We'll explore this further in the demo. Alright, so now we're talking about System D. System D is the init system for Rocky Linux and CentOS and the service manager for a Debian OS. It's the very first process that starts when Linux boots. It orchestrates the boot sequence, manages system resources through control groups, and controls background services. Its PID is always 1, PID being process ID. Every other process, including the shell that you're typing in, is a child of system D. If you kill PID1, the machine reboots. That's how central system D is to the operating system. Now we move on to systemctl. Systemctl is a utility used to control and introspect the system D service manager in Linux distros. It allows you to manage background daemons, view system states, and configure startup behavior. When a service behaves unexpectedly, systemctl status is the first command you run. Some few key distinctions that you need to know. Start runs the service now. Enable ensures it starts automatically on boot. If you start a service but you don't enable it and the node reboots, your fix disappears. Another distinction you need to note is reload and restart. Reloading applies your configuration changes without dropping any active connections, and restart will stop and start the service, and it does interrupt your connections. Reload is critical for services like web servers and NFS where downtime matters. Right, so we're going to look at this quick example of how to read a systemctl status output. So here's how we interpret it. We look at the service name, we identify it, and here, as we can see, it's an open SSH server, so it's an SSH daemon. We check whether it's enabled at boot, we check whether it's active and running, we note the process ID, and we review the recent logged entries. journalctl is another utility used to further query and display logs generated by the systemd journald logging service in Linux. Logs are sysadmin's best friend. When a service fails, the first thing you do is run journalctl-xe or your journalctl-u, your service, and you choose the number of times, which maybe you would choose 50. You could add -f to watch a service come up in real time. A good tip is to run journalctl-p, your error since today, because it gives you all the system errors since midnight, which is very helpful. Alrighty, then we're looking at the service states and boot behavior. This is just a quick one, but the difference between enable and start is crucial. If you fix a service during the competition and only start it, but don't enable it, the next reboot you do will undo your fix. Always enable critical services. Okay, so some common mistakes to avoid. Firstly, would be starting without enabling, as mentioned before, not checking your logs when it fails, forgetting sudo, sometimes that's all it takes, restarting instead of reloading, masking versus disabling, and port conflicts after restart. My personal opinion would be to focus on your starting versus enabling and checking logs. That should actually just be your first instinct, but everything else is also super important. Okay, so we're going to look at the Linux essentials first. So pwd just stands for print working directory, and that just shows exactly where we are. So first we're going to make a directory. That's what that stands for. I'm going to call it chpc demo. And then we're going to cd, which means change directory, into this new directory. Okay, cool. And then now we can see where we are. This is our new directory that we made. Awesome. Let's clear that. Okay, first we're going to make a directory, another one. We're going to call it path1. And we're going to create a document and edit it using Nano. Nano is a file or a text editor, sorry. I'm going to call that example 1. Okay, we're going to paste this text right here. Alrighty, let's save that. So you Control O and then Control X, and that's how you save a text file using Nano. And yeah, let's see what we can do with that. So cd ... means you're going to go to the previous directory. So we're going to go back, and now we're going to look at cat, and cat basically allows you to just peek into your document without having to edit it. So we're going to be looking for this and our example, and yeah, as you can see, we just get to look at it from there. Another thing we can also do is we can use head, which just shows you the first few lines of the document instead of the entire thing. And as you can see, that's the first couple of lines of that document. And we can use tail, which shows the last few lines of the document. And that's what we can see. So yeah, what else can we do there? Not much. So okay, we can move on to grep. So what grep is popular for is it allows you to look through your files and you can find some keywords, which is super useful. So for example, we can recursively search for the word or the term CHPC, and we can look for it in our current directory. That's what the dot is for. Or you could type out the entire directory. Depends where you're looking. So you can look at your roots, you can look at home. So it's just completely up to you, but we're going to look at the current directory, and they found it in the example that we made, and it found it over there. So grep is really cool for that. There's a lot of other uses, but this is a very easy one to kind of get you started. Okay, so another cool tool to use is find. It's similar to grep, but here you are looking for file names over finding the actual text within a file. So for example, we can find in this current directory by the name, or rather, let me actually show you. Firstly, this is what we have in this current directory. And if we list part 2, we see all these log files. So I just want to show you what find can do with a very small example. So we can say find in this current directory by the name, and then we're going to use a star *.log, because that's going to tell us, okay, look for all the files that end with a .log in this current directory. Okay, cool. So let's see what it does. And of course, that's what it does. It found all our example log files under part 2's directory. So that's also pretty cool. Okay. So one more thing I can share with you are permissions. Let's move to the demo and let's list everything. So as you can see here, with example 1, we've got different permissions for different users. So this first part is kept for telling you if it's a directory or if it's a file. So as you can see D here, because that is a directory, but this is a file that we created. The next 3 show the owner permissions. The next 3 show group permissions, and then the last 3 show others. This shows how many files, the number of files there are, and then this is the file owner, and then this is the group owner, and this is the size, etc., etc. So we'll go into detail later on, but I just wanted you to know this for now. So if we wanted to, oh, actually, let me get that back. If we wanted to change the permissions for this example 1 file, what we could do, well, one of the things you could do, there's a couple of ways to do this, is to, because what was that? Anyways, ta-da! So as you can see, it's green because now we've made it an executable file for the owner. Like I said, we'll go into more detail later on in the competition, but for now, that's all you need to know. Okay, so here I'll be going over a brief example of generating a key pair, an SSH key pair, using the ED25519 secure algorithm. I didn't choose a passphrase because it wasn't really necessary, but you can generate your own passphrase if you want it to be more secure. So as you can see, it gives you a fingerprint. As we can see, we have our known hosts and our private and public key. And there's our private key, which I have changed. So now we can SSH into our machine. But then we need to make sure that when you have a node that you're SSHing into, that node must be familiar with your public key, which is associated to your private key, hence the key pair situation that comes in there. But pretty straightforward. We will be doing this further in the selection round. Okay, so now we're just going to go over some Linux networking fundamentals. To start, we'll start with IP address show. And the first interface is the loopback interface, which is basically internal networking. And then the second interface is your actual network interface. As you know by now, the public IP address is used to SSH into the node, but here we can see that we have our private IP address. And yeah, we have the private IPv4 address here of this node. So nothing crazy, but this is super useful. Then we also have IP root show. So here it shows us the default gateway is this address over here. All non-local traffic goes through it. And then we have this address here, which is our local subnet, meaning machines from 10.0.0.0 to 10.0.0.255 are directly reachable. And this last section over here is the cloud metadata server, which isn't really important, but it's actually kind of interesting. It tells us that we're on the virtualized HPC or cloud head node, and well, in our case, the HPC head node, and the system reaches it through this 10.0.0.100 address. So yeah, that's what we've got over there. And we can also use ifconfig, but ifconfig is like an older version of IP address show. It shows the exact same thing. It's up to you really, but I would prefer using IP address show. Okay, cool. Let's move on to firewall D. Firewall D, I'll explain this a bit later, but let us first download it or install it. Install firewall D. I think I already did this, yeah. So it's already installed. And because it's firewall D, as we know, D stands for daemon, so it's a Linux service, so it has to get initialized. It has to be enabled. So we're going to say sudo systemctl enable now. Enable now. Oops. Anyways, then we can sudo systemctl status of firewall D, and then as we can see, it's active and it's running. So firewall D is basically a high-level way to see your firewall. It'll make more sense during the selection round, but that's essentially. Some commands you could run would be sudo firewall cmd state, and then that just checks the state of the firewall, which is running. We've got sudo firewall cmd, so this basically lists all the active rules, allowed ports and services for your default zone. We haven't really set any rules. This is just for practice, but you should be setting some firewall rules here. Let's clear this up a little. So yeah, that is firewall. The most used tool though in HPC would be your NF tables. We already installed that. So NF tables are used a bit differently because it's a lower level version of your firewall D, and it's more granular, and you're able to manage the rules more specifically. So you could use commands like this, list rule set. As you can see, many rules here. But like I said, this hasn't been configured correctly, so please don't use this as a template. Let's clear that a little. Another example would be tables, and that's what we got. So that is just a little brief overview of how to use the different firewall tools in Linux. Two more things I also want to show are ping. Ping is pinging. You are trying to connect or reach a certain server, and let's say we want to ping our own server, say maybe com1, for example. We can go, yeah, I think it's com1, yes. And basically it's going to ping 4 times, and as you can see, 4 packets were transmitted, 4 were received, and 0 were lost. So that is a good thing. So that's also pretty useful, as well as this command right here. So this basically shows which ports are listening, which aren't, where they're listening from, and this is also super useful. As you can see here, we've got SSH is open, we've got NFS open here as well, and listening on all interfaces. Basically, listening basically just means that it's actively monitoring that port and it's waiting for any incoming connection requests. So yeah, that is that for some networking basics. So as you can see, we have this basics sh file. So let us see what's in there. So yeah, very simple bash script just for now, just so you can understand how it works. So this is how we declare our variables. Like this, your variable name or your variable has to be right by the equal sign. Syntax is very important here. This is command substitution. It's basically where you run the command that you run in the terminal, but then you store it in a variable name. You've got if statements as well. For example, here, if this number 5 is greater than 3, then you've got your if else, and that's how you end your if statement. You've also got loops in here, as well as generating your own functions if that's what you want. And lastly, also reading user input. So this is just a very basic bash file. I just want to show you how we'd also execute it. So first we were going to change that, and this basically makes the file an executable. Let me first show you that it's not an executable. Change mod +x, and now it is. And so for it to be executed, we have to then also do this. So first you make it an executable file, then you execute it using // and then the file name. And there you go. Now we've basically run our bash script, and very simple. Like I said, just so you can understand how this works. My favorite number is 4, and I've entered 4, and that's about it. So like I said, we'll be going through scripting in more detail during the selection round. Okay, the last 2 tools I want to go over are systemctl and journalctl. So with systemctl, we would do something like this. Let's look at our SSH service, the daemon. Okay, cool, this is interesting. So as you can see, it is very much active and running. We can see the server name as well, or service name, OpenSSH server daemon. We can see that it's running and it's active as well. What we can also see are the logs at the bottom, which are very important. And if you look closely, there were some invalid users trying to SSH into the node a couple of times. But besides that, this is super crucial for when you want to debug a certain service not working. We can also, if you want to, sudo systemctl, we can also stop it, and then we check the status again it's been stopped, it's inactive, right? And we can just start it again. Pretty straightforward, nothing crazy. It's pretty straightforward, nothing crazy. As you can see here, when we stopped this daemon, it did say over here, terminating, stopping the service, and then when we start it again, it does tell us in our log file. So that is super, super important. Alrighty, what else can we look at here? We can also reload SSH, but I'm not going to do that right now because I'm going to stop it again. Stop SSH. Sudo. Let's not do that. We're going to sudo. We stopped it. And then we're going to check the status again. It's been stopped. Something I wanted to share is that when we'd like to reload after making some changes, it won't interfere with the current network, the current connections rather, and everything stays up. But if we try to reload from a service that's not active, nothing's going to happen. It won't work. So it's very important to know that distinction between reloading, restart, stopping, starting a service using systemctl. And to quickly go over journalctl, almost similar to systemctl but more in depth and gives you more logs. Let's run xe first. So as you can see, much more in depth and much more detailed than systemctl. And so this is what's super beneficial about journalctl, is that you get much more details in your log files. Let's clear that a bit. So another one we can run is your journalctl uSSHD. Let's do a number of times 50, and we can use that flag for just like a live update on SSHD. So this gives us everything that's happening to our SSH service live, and as you can see, we're opening and closing all the time, and that was picked up in the log files. So every single thing that happens to your SSH service is picked up in the journal log files, which is really cool. Okay, let's clear that up a little. Another thing that's also really helpful, another command that's really helpful rather, this basically is it tells us it prioritizes the errors, and it tells us from today what errors have they logged, or has the system logged in the journalctl. And as you can see, there have been no entries, which is good. Another one that's also really helpful is journalctl and then your service name. We're just going to use SSH again since today. And this is a lot, but these are all the logs from any activity that happened with the SSH service today. So yeah, those are some basic commands for systemctl and journalctl. Okay, cool. So now that we have the basics down, the following sessions will build on our Linux knowledge, and that includes our system admin and configuration, which I will be teaching, the NFS and file systems basics, your schedulers and monitoring, as well as scripting and automation. All right, thank you for listening. If you have any questions, I will be at the selection round with my team in person, so it'll be really fun to engage with you guys. Bye.